Permutations and combinations. In permutations, order matters. In combinations, order doesn't matter. Permutations are for lists, while combinations are for groups. The permutation formula is permutation n choose r equals n factorial over n minus r factorial. The combination formula is combination n choose r equals n factorial over n minus r factorial times r factorial. So you saw how I wrote permutation and combination, but maybe you were wondering what the n and r stand for. N stands for the total number. R stands for the selection or sample of the total. Now maybe you were wondering what factorial is. Well, I'll tell you. Factorial is the product of an integer and all the positive integers below it. For example, 4 factorial would be 4 times 3 times 2 times 1. Now something you should know is 0 factorial is equal to 1. I've heard it compared to you can only have one set of nothing. That's probably the easiest way to understand it. So what do permutations and combinations solve for? Let's say you have a total number of items and you want to find the number of ways you could order any amount of them. Or more simply put, using the variables n and r, you have n items and you want to find the number of ways r can be ordered. Now for a permutation example. There are 7 contestants in a race and only 3 prizes, first, second, and third place. So let's write it out in our equation. Permutation 7 choose 3 equals n factorial over n minus r factorial, which equals 7 factorial over 7 minus 3 factorial, which is 7 factorial over 4 factorial. And you could just plug that into your calculator and it would give you the answer. But I'm going to write it out here. So 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 4 factorial 4 times 3 times 2 times 1, which cancels out, leaving us with 7 times 6 times 5, which equals 210. Now to help you understand this better, I'm going to write it out. We have 7 contestants and 3 prizes, first, second, and third place. So there's 7 people that could get first place. But once first place is taken, there's only 6 people that can get second place. And once both first and second place are taken, there are only 5 people that could get third place. So we multiply 7 times 6 times 5, which gives us 210. You're standing in line at Starbucks and there are 3 people in front of you. That means there's a total of 4 of you in line. Now we want to know how many different ways could these 4 people in line be rearranged. So to figure this out, since it's a permutation, we put it into the equation. Permutation 4 choose 4. Now, since n and r are the same number, we can simplify this by simply turning it into that number factorial. So in this case, 4 factorial is our answer. Now for a combination example. There are 6 people waiting to see the president, but only groups of 3 are allowed to see him per session. So how many ways could those 3 people be picked? Remember, order doesn't matter. So that would be combination 6 choose 3, and our formula here, n factorial over n minus r factorial times r factorial equals 6 factorial divided by 6 minus 3 factorial times 3 factorial equals 6 factorial divided by 3 factorial times 3 factorial. That equals 6 times 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1 times 3 times 2 times 1. 3 times 2 times 1 cancels out, leaving us with 6 times 5 times 4 divided by 3 times 2 times 1. That equals 120 divided by 6, which equals 20 different ways those 3 people could be chosen. Now I'll try and visualize it for you. So we have 6 people and 3 places in the group. There's 6 people available to be put in the third place in the group. Once that third place is filled, there's only 5 people available to fill the second last place in the group. And then after those 2 people have filled it, there's only 4 people available to fill the last place in the group. So since it's a combination, we multiply out the top and multiply at the bottom and divide.